This video is on simplifying expressions using the greatest common factor, and it's lesson 38 in your book. The two types of numbers that we're dealing with are composite numbers versus prime numbers. Now, composite numbers have whole number factors other than 1 and the number itself. For example, 4 is a composite number because not only do 1 and 4 go into 4, but also 2. Prime numbers are whole numbers that are only divisible by 1 and themselves. For example, 2 is a prime number because the only thing that you can multiply to get 2 is 2 and 1. Now, before we can do these problems, we need to know about prime factorization, or how to find the prime factorization of a number. Now, here's one way. We know that 120 is 2 times 60, and 2 is prime, so we'll keep it. And we would split 60 up into 30 times 2. So then we have two 2's that are prime, and then 30 is 15 times 2, etc., etc. Now, another good way, and the way I always use, is a factor tree. So we start with the number that we're trying to factor. And we say, okay, what can I multiply to get 120? Well, I can multiply 2 and 60. Now, 2 is prime, so its branch ends there. 60, we can multiply 30 times 2. Again, 2 is prime, its branch ends. 30 is 15 times 2. 2 is prime, so its branch ends. And then 15 is 3 times 5. Now, all the ends of the branches are my prime factorization. So I could say 120 equals 3 times 5 times 2 times 2 times 2, because I have all these end branches here. Or I can even rewrite that as 3 times 5 times 2 to the third power, because I'm multiplying 2 3 times. Alright, so again, our prime factors are 2, 2, 2, 3, and 5. Now, monomials are a little different to find the greatest common factor of, only because they contain letters. The greatest common factor of a monomial is the product of the greatest integer that divides without a remainder into the coefficients and the greatest power of each variable that divides without a remainder in each term. Now, that sounds really confusing, but basically, it is the product of all the factors that each term has in common. Now, to find the GCF, you find the largest monomial that divides without a remainder into each term of the polynomial, or you find the product of all the factors that each term has in common. Now, here's an example, and this needs to be in your notebook. We want to determine the greatest common factor of this algebraic expression, 6a squared b to the third plus 8a squared b squared c. Now, in order to do this, we need to find the prime factorization for both terms. So I'll start with finding the prime factorization for 6a squared b to the third. Now, 6 is 2 times 3. So 6's prime factorization is 2 times 3. Now, we don't know what a is, but we do know that a squared is a times a. So I can rewrite that as a times a. And I don't know what b is, but I do know that b cubed is b multiplied 3 times. So b times b times b. Alright, now I'm going to put a plus at the end here because I have 6a squared b cubed plus this other term. So I'm just going to leave my plus out here so I can remember it. Now, 8 is divisible by 2 and 4, and 4 is 2 and 2. So if we were to write the prime factorization of 8, it would be 2 times 2 times 2. Then we have a squared. Again, that's a times a. And then we have b squared, so that would be b times b. And then we also have c to the first, so there's just one c. Now, to find the greatest common factor, we want to find all the factors that are common to both terms. So here's the prime factorization of the first term. Here's the prime factorization of the second term, and we need to see what do they have in common. So look at this. They both have a 2. So 2 is going to be part of our greatest common factor. Now, this one's got a 3, this one has some more 2s, so that's all for our whole numbers. They both have an A, and then another A. So our greatest common factor is going to include A and A. They both have a B here, so that's another part of our GCF. They both have another B in common, so that's another part of our GCF. So that means that our greatest common factor for these two terms would be 2 A times A, which is A squared, and B times B, which is B squared. So 2A squared B squared is our greatest common factor. Alright, here's another example. We want to find the greatest common factor of this polynomial. Now remember, this needs to be in your notebook. What I'm going to do is I'm going to factor each term separately. So I'm going to start with 8c to the 4th d squared e. 8, remember, factors into 2 times 4, and 4 factors into 2 times 2. So 8 is 2 times 2 times 2. C to the 4th implies that I am multiplying C 4 times, so 1, 2, 3, 4. D squared tells me I'm multiplying D twice. And then finally I have an E. Now this next term is 12C to the 3rd D to the 4th E squared. So I have to factor out my 12. That's a 3 and a 4. And then 4 is 2 and 2. So my prime factorization there would be 2 times 2 times 3. Then I have C to the 3rd, so I've got 3 C's. And then I've got D to the 4th, so 4 D's. And then E squared, so 2 E's. Now, to find my greatest common factor, I need to figure out what these two terms have in common. That's why I stack them on top of each other, so then it's easy to see where they match up. Here I have a 2. That's going to be part of my greatest common factor. Here they have another 2 in common, so that's the other part of my greatest common factor. They don't have a 2 and a 3 in common, but here they've got a C, so there's another one. Here's another C. And here's another C right there. Whoop, supposed to enclose that. Alright, now this one has another C and this one doesn't. But look, they both have this D right here. Whoops. There's our D. Okay, then they have another D in common. And then finally, they've got an E. So our greatest common factor here is 2 times 2, which is 4, C times C times C, which is C to the 3rd power, D times D, which is D squared, and then E. Alright, so when we're factoring a polynomial, we want to find the GCF of the terms, and then factor the GCF from the polynomial. Now, here's what we're going to do. Again, this is an example. It needs to be in your notebook. I'm going to find all the factors of 6x to the 3rd. So 6 would be 2 times 3. So that would be 2 times 3 times x to the 3rd, or 3 x's. Plus, now my next term is 8x squared, and I've already factored 8 several times. It's 2 times 2 times 2. And then x squared is x times x, minus 2x, and my only factors there are 2 and an x. Now, in order to factor out this 3-term polynomial, I have to look at what factor do all 3 terms have in common. So notice here that they all 3 have a 2. So I'm going to write that as part of my greatest common factor, 2. Now, they don't all have some more numbers. However, they do all have an x. So that would be the other part of my greatest common factor. So the greatest common factor of this polynomial is 2x. Now, we want to factor this polynomial completely. So we want to know what can we multiply 2x by to get what we started with up here. So here's my greatest common factor, and next to it I'm going to write a parentheses. Now, what I write in this parentheses is what I can multiply 2x by to get my original polynomial. And how I find that is I look at what factors do I have left in my factorization. So 2x times 3 times x is what will get me 6x cubed. So I put 3x squared right here. Then a plus, of course, because I'm adding. Now 2x times 2 times 2 times x is what will get me 8x squared. So 2 times 2 times x is 4x. Then there's a minus. And then 2x times what will get me 2x? Well, there's nothing left in this factorization here, so I just write 1. Now this is the factored form of my polynomial. And if I were to distribute this 2x to each term inside the parentheses here, I would have 6x cubed plus 8x squared minus 2x. Alright, now here we want to simplify these fractions using the greatest common factor, and these do need to be in your notebook. So we'll start with 3p plus 3. Now I want to factor out 3p plus 3. So my prime factors of 3p are 3 and p, and I've got plus, and my prime factors of 3 are just 3. Now the greatest common factor here is what they have in common, so it's 3. Now what do I have to multiply 3 by to get 3p? Well, I have to multiply it by p. And then I've got a plus. Now what do I have to multiply 3 by to get 3? I have to multiply it by 1. So what I really have is 3 times p plus 1 over 3. Now notice here that I have 3 divided by 3, and my 3's cancel, and I'm just left with p plus 1. Now here in our last example, I have 5x minus 25x squared all over 5xy. Now I'm going to find the greatest common factor of this numerator. So my factors of 5x are just 5 times x, then I've got a minus. My factors of 25, I know 25 is 5 times 5, so I've got 5 times 5, and then my factors of x squared are x times x. Now my common factor is what they have in common, so here they've got a 5, and they also have an x in common. Now what do I have to multiply a 5x by to get 5x? Just 1. Then I've got a minus. What do I have to multiply 5x by to get 25x squared? 5 and x. And then that's all over 5xy. Now this makes my life really easy because the 5's cancel, the x's also cancel, and I'm left with 1 minus 5x all over y.